All right, so in the last video, we began this process of 8.2 and graphing it, where it was ax squared plus c. Now, we realized after some examples that the c values simply controlled the up or down of the overall function. So if I had a parabola, such as this one right here, if it was a positive, if the c was a positive, it would just move it up. However, if the c was negative, then it would bring it down and didn't do anything else other than that up and down motion. So now we want to add another piece to this, another layer to it. In the 8.1, we had learned about the a value and how it affects the overall graph. So, for instance, we have a 1/4 for the a. What does it do to the overall graph? Because this is our parent function. This is y equals x squared. So what does the 1/4 do? Can we recall back to 8.1? Well, first off, we already know this plus 2 will do something. And we can go ahead and write that at the bottom. It will be a translation or translate up, because it's a plus, 2 units. So we already know that this graph is going to be shifted up 2 units. But now we just have to see what does the 1/4, and hopefully we can remember that from 8.1. But let's fill this table out and quickly graph the effects. So I just picked some values and plug them in for the x position. I still have to square it. I still have to basically divide it by 4. That's what multiply by 1/4 is. It's dividing by 4. And then add 2. So when I take -6 and square it, that's positive 36. And then I would divide it by 4. 36 divided by 4 is 9. I add 2 to that. That is 11. So I can graph backwards 6, 1, 2, 3, 4, 5, 6, and up to 11. Now this is 10, so 11 is just right there on the edge. Oops, and I've lost where -6 was. 3, 4, 5, 6. And then there we go. It's right there. Let's do it again. -4 squared. That's 16. Divided by 4 is 4. Plus 2 gives us 6. So this time I'm going to go backwards. 1, 2, 3, 4, and up. 1, 2, 3, 4, 5, 6. When I switch over to my pen, I always lose where I was at. Okay, again, -2 squared. -2 squared is a positive 4. And when I divide it by 4, well, that's just 1, because 4 divided by 4 is 1. And then when I add 2 to that, 1 plus 2 is 3. So this time I'm going to go backwards 1, 2, but I'm going to go up 1, 2, 3. What about the next one? 0 squared is still 0. Divided by 4 is still 0. Plus 2. Well, 0 plus 2 is 2. So 0 means that I've gone nothing left or right. I'm still here at the middle. But then plus 2 shifts me up 2. So there we go. Now, what about positive 2? Positive 2 squared is 4. Divided by 4 is 1. Plus 2. 1 plus 2 is 3. So this time I go forward 1, 2, and up 3. Next one, 4 squared is 16. Divided by 4 is 4. Plus 2 more is 6. So I'm going to go over 1, 2, 3, 4, and I'm going to go up to 6. And last but not least, 6 squared we said was 36. Divided by 4 is 9. And we add 9 and 2, we get 11. So I go over to 1, 2, 3, 4, 5, 6, and I go up to 11. There we go. So now, when I draw this out, what happened? Well, we can already see that the bottom, this vertex, from the parent function did indeed shift up 2. And we are used to it shifting up 2 because, well, that's what the plus 2 is about. But what about the fact that it is wider than the original parent? Well, as you learned in 8.1, that widening effect is called a shrink. Now, how much did it shrink? How much did it shift things? Well, I want to zoom in on this example right here. Normally, it was at -2, +4. But now the point is down. And how much did it move down in comparison to, say, the bottom or the x-axis? Well, if it was originally 4 units up, it went down one of those 4 units. It went down 1/4. Hey, wait a minute. 1/4? 1/4. So it's a shrink. When it widens, it's called a shrink. And how much did it shrink? Well, 1/4. And I'm going to kind of put in parentheses widens. That's what shrink means. It widens. It's not like what we're going to see in the next example, where it narrows. We have a 2 in the next example. This one widened, and widening is always a shrink. And how much does it shrink? Well, it shrinks based on the a value. So let's do one more. And this time we're using 2x² - 5. So I've already written all out everything I'm going to do. I've already shown what I'm going to plug in. So we just quickly go through all of these. -3² is 9, +9, times 2. Well, that's 18. If we minus 5 from that, that gives us 13. So if I were to go graph this, it would go backwards 1, 2, 3, but now it's up at 13, which, it's probably about right there. Let's do it again. -2² is a +4, times 2 is 8. Minus 5, 8 minus 5 is 3. So when I go over to -2, let me check that again. I feel like I said something wrong. Let's try that again. 2² is 4, times 2 is 8, minus 5 is 3. Yep, okay, perfect. So I'm going to go backwards 1, 2, and I'm going up to 3. 1, 2, 3. Now, let's go to the next one. -1². -1² is 1, times 2, well, that's just 2. But 2 minus 5, that is a -3. So when I go over to a -1, because that's what I plugged in, I have to go down to 1, 2, 3, to this -3 position. 0². 0² is 0 times 2 is still 0, but minus 5, hey, look at that. It's minus 5. So 0 means I didn't go left or right, but now I have to go down 1, 2, 3, 4, 5. Again, 1². 1² is 1. Times 2 is, well, 2, and 2 minus 5 is -3. So now I plugged in a positive 1, but it got out a negative 3. Two squared is 4, times 2 is 8, 8 minus 5 is 3. So now I go over to 2 and up to 1, 2, 3, up to a positive 3. Last but not least, 3 squared is 9, times 2 is 18, minus 5 is 13. So when I go over to positive 3, I'm way up here again at 13. Now, before we even began plugging in these points, we should have already known some of the things that's going to happen to this, such as the minus 5. We would realize that that is a translation down because it was a minus. How far did it go down? It went down 5 units. Because, well, it's a minus 5. So if minus means down, 5 means that's how many units it went down. Which means that the overall equation is going to shift down 5 units. 1, 2, 3, 4, 5 units. Now, that's not the only transformation that has happened. That was the first transformation that we could see by doing things. What was the second? Well, notice that the parent function is not as it's wider than if I were to. In fact, I needed to draw this. Let me draw this real quick. It's wider than if I would have drawn in the other one. That means that this equation narrowed. Well, narrowed why? Well, again, we learned in 8.1 that the a value makes a difference. And if it is a number bigger than 1, it's going to narrow. In this case, it is a 2. So it definitely narrowed. We call that a stretch. So it stretched by a factor of 2. And I will write in that word I used, narrow. Ooh, if I could spell it. I don't even know how to spell that. Man. Narrowed. I don't know if that's right. That's probably not how you spell narrowed. Anyways, it stretched out. Now, one of the easy ways to see that it was a 2 that it stretched by is when we go down here to where the vertex of both our parent now and the new function is they both start here, but the parent function only, when I go over 1, it only went up 1. But the new function, the one in this purplish color, if I go over 1, it went up 2 units away. So it doubled its distance away. Well, doubling means times 2. And sure enough, there's a 2 for the a value. Likewise, we could see that with the next point. If I go over 2, this is 1, 2, 3, 4 units up on the parent. But on the purple function, it is 1, 2, 3, 4, 5, 6, 7, 8. It is 8 units. It's twice as far away. Hence, the 2 tells us it's going to double the distance away. All right, so highlights on this one. We still know that the C value moves it up or down. If it's a positive, it goes up. If it's a negative, it goes down. We also remind ourselves from 8.1 that based on what the a value is, it can widen if it's a fraction that has the bottom greater than the top. Or it can narrow. By the way, this was called a shrink because it widened. Or it can narrow, or what we call stretch, if it's a number greater than 1. So between 0 and 1, greater than 1. Shrink widens, and it happens with values that have the denominator larger than the numerator. That would widen the function when it's between 0 and 1. And it stretches when the value is greater than 1. All right. Thank you for your time.